All right, let's get started. Welcome, everyone. This is the Science and Values in Climate Risk Management webinar series. I'm Casey Helgeson from EASY, the Earth Environmental Systems Institute. I am one of the co-organizers of this webinar series, along with Nancy Tuana in philosophy, Klaus Keller in geosciences, and Rob Nicholas, also like me in EASY. And we do this with support from Penn State's Rock Ethics Institute and Center for Climate Risk Management. So I'm just going to tell you a little bit about how to participate in the webinar today. Then I'll introduce our speaker. Professor Lloyd will then present for about 40 minutes, and we'll have about 15 minutes for Q&A at the end, and we should end by 5 o'clock. So to participate in the Q&A, you can do two things. One, you can type into the chat questions at any time. And when we get to the end, I'll read questions out of there. Second way is to use the raise hand function during the Q&A. This is preferable if you're willing to speak your question. And beyond that, if you want to continue the discussion after the webinar today, there will also be follow-up discussion with Professor Lloyd tomorrow at 11 a.m. I'll put the link to that into the chat a bit later during the webinar. So let me stop my screen share for a moment and introduce our speaker. So our speaker today is Elisabeth Lloyd. She is a distinguished professor at Indiana University's Department of History and Philosophy of Science and Medicine. She did her PhD at Princeton University, and before arriving in Indiana, she was also previously a professor in the philosophy departments at UC San Diego and UC Berkeley. She has a very long list of highly cited books and articles. Earlier in her career, she worked primarily in the philosophy of biology. And in the last 10 to 15 years, she has, in addition, been one of the pioneers among philosophers of science engaging with climate science, including many collaborations with climate scientists at the National Center for Atmospheric Research and elsewhere. So one of the topics in climate science that she has published a number of papers on across both the philosophical and scientific literatures is on the attribution of climate change in extreme events. And that's what she'll be speaking about today. Professor Lloyd, thank you so much for being here.
It's wonderful to be here, and thank you so much for your kind introduction. I'm going to turn on my share screen. Okay. Now, I want to note that this is from work with Naomi Oreskes at Harvard and Ted Shepard at Reading in England. And we can start with the idea that given that climate change is a fact, that might imply to some folks that the recent extreme weather events are in part caused by climate change. Climate scientists, however, know that the situation is more complex. There have always been extreme events. So as our climate changes, there will be extreme events that would have happened without human-made causes. And by that, I mean without the aggregate effect of anthropogenic greenhouse gases, aerosols, etc., on the radiative balance. But I am not going to say that every time. Within climate science, the field of detection and attribution, known as DNA, that's D and A, not DNA for the biologists here, concerns the detection of anthropogenic effects on climate. The attribution part concerns how much or how severe these effects are. That is, how many degrees of temperature, how much extra precipitation or wind or hurricane force is due to the increase in anthropogenic causes like greenhouse gases. In other words, to what extent is a given extreme event or pattern of extreme events attributable to the increase in greenhouse gases? Now, clearly, this is a driving question of the day, especially as it relates to local droughts, floods, storms, as well as wildfires. Think of the fires in California. The methods used to attribute extreme events, the common ones, were first developed and applied in 2003 and 4 in England. Peter Stott, who was the head of Climate Monitoring and Attribution Group and the Hadley Center at Exeter, part of the Met Office, and Miles Allen and Freddie Otto and their colleagues at Oxford, they developed the now conventional probabilistic technique for attributing climate change to extreme events. It involves examining the event as one in a class of events like heat waves, floods, droughts, and using climate models to compare the probability of the event under current factual conditions, represented as P1, with its probability under counterfactual conditions, represented as P0, in which the climate, contrary to fact, did not undergo greenhouse warming and anthropogenic changes in general. The relevant probabilities are arrived at through studying climate models as well as empirical data. In this risk-based approach, the primary objective is to estimate probabilities and related diagnostics, such as what you have here, the fraction of attributable risk and the risk ratio. For the rest of the talk, I'm going to refer to this as the risk-based or sometimes probabilistic approach. But in a set of recent papers, well, within the past decade, Kevin Trenberth and his co-authors, John Fasulo and Theodore Shepard, as well as the unrelated group Alexis Hannard and colleagues, as well as a group in France, argued that climate scientists' approach to DNA studies should include a set of additional complementary methods. Shepard contrasts the now conventional risk-based approach with what he dubbed a storyline approach that seeks to explain the origin of singular events rather than classes of events and the influence of climate change and other causes on those events, acting as a kind of autopsy of the extreme event. One of the most urgent things that I had for several years been trying to convince people of in my talks, papers, and conversations is that a storyline approach to climate attribution uses a special logic in its research questions, distinct from the traditional attribution methods used in the field, which make it especially useful and applicable for some purposes. In answering the attribution problem of extreme events, that is, to what extent is a given pattern of extreme events attributable to the increase in greenhouse gases, they lead with a distinctive research questions of the storyline approach. Given whatever conditions they want to keep constant, what is the effect of climate change on the impacts in that system? This is usually done on a regional level, and it's usually done relative to particular questions about particular impacts, such as excess rain, excess warming, or excess dryness, all leading to damaging consequences, such as fire or flooding or drought, to human systems of farming, livelihood, and sustainability. These questions are asked in an analogous way to those in an autopsy or accident investigation, as Shepard notes. The storyline approach is analogous to accident investigation, where multiple contributing factors are generally involved and their roles are assessed in a conditional manner. Shepard says the most useful level of conditioning will depend on the question being asked. A storyline is a physically self-consistent unfolding of past events or of plausible future events or pathways. And by the way, that distinguishes it from the risk-based approach, which is strictly about past events. Now, when considering the logic of research questions, an approach I introduced in 2015, I emphasized that a given research question is associated with a specific set of responsive and possible answers, given the theoretical and conventional constraints of the science and scientific community. The approach to analyzing research in terms of the logic of research questions means including consideration of the results between the research questions and their possible responsive and appropriate answers. Take the risk-based research question asked in typical DNA of extreme events. What is the probability of a specific class of weather event given our world with global climate change relative to a world without global climate change. The risk-based approach has possible and responsive answers that are listed here as the risk will increase, will decrease, or will be unaffected by climate change. In comparison, consider a simple storyline research question here. Under the conditional state of the extreme event, how did climate change alter its impact? And possible and responsive answers are that climate change made the event more or less severe or had no effect on the impacts. In essence, they're proposing a conditional format. Given the atmospheric dynamics that brought about the event, how did climate change alter its impact? Let's look at the logic of research questions and possible responsive answers for a storyline account of the Boulder, Colorado flood of 2013, a controversial extreme event. A research question under the storyline approach might be, given that the Boulder, Colorado flood of 2013 happened, how did climate change affect the severity of the flood, all other things being equal? Note that this research question assumes that the Boulder flood occurred when and where it did, and also assumes all the weather and climate dynamics associated with its occurrence. On Trenberth's account, Trenberth et al.'s account, climate change led to increased water in the air, which was funneled into the Boulder flood from down south, thus increasing the amount of rainfall and thus the severity of the flood itself. That's a typical answer to a storyline extreme event question. It concerns the single event and some of its causes, including climate change and thermodynamics in the absence of adequate dynamical modeling. One scientist who is unconvinced by the argument to reconsider the scientific approaches to analyzing extreme events is Martin Hurling of the U.S. National Oceanographic and Atmospheric Administration, NOAA, a meteorologist who was responsible for the first study of the Boulder flood of 2013. He and his colleagues concluded there was no effect from global warming. If anything, they said climate change may have made the Boulder event even less likely. Now, the National Academy of Sciences, in their 2016 study on DNA, said that the approach and framing, in my terms, the logic of research questions, of an attribution study may affect its actual conclusions. In fact, on my view, that's true of any scientific study. In addition, Trenberth et al. Criticized the dynamical portion of Hurling's models, saying that they did not have a high enough resolution model to make judgments about the amount of precipitation present in the Boulder flood or to model where it came from. This point was later taken up in a 2017 paper by Party Paul et al., who use a combination of risk-based and high-resolution storyline autopsy methods to give a mechanistic model for the flooding in Boulder. They conclude the greenhouse gas drivers increased the magnitude of heavy Colorado rainfall for the week of flooding by 30%, using both risk-based and storyline methods. Now, I find this a lovely and very contemporary paper because it demonstrates what Shepard argues from the first about the complementarity of the storyline and risk-based account, using both to strengthen its results. This is a contemporary position that Naomi Oreskes and I have endorsed for the two methods. So from the vantage of history and philosophy of science, as well as more recently, a growing number of the scientists, the idea that under conditions of secure knowledge, it's appropriate to attempt to explain causal pathways and mechanisms of individual events seems entirely non-controversial, especially when the dynamics of the situation may seem unavailable. Now, working with Naomi Oreskes and Ted Shepard, we emphasized that the different approaches to attribution analysis, the risk-based and storyline approaches, had different approaches to preferred error. Under the risk-based approach, they took a standard approach to error, preferring to avoid type 1 error. That's false alarms that they're trying to avoid. This is the classic setup of the propensity of risk-based methods towards statistical errors of underestimating harm. And this brings us to an arguably very important point, which is that overstatement of human effects, a false positive, which is the kind of error risked by the storyline account, is perceived by the risk-based DNA community of scientists to be worse than understatement, a false negative, risked by their own account. But the storyline folks, on the other hand, were more concerned to be the most informative and not to miss events that might endanger society, and so preferred to avoid false negative errors on account of this social value. Just as in cancer medicine, we prefer to err on the side of false positives in screening, the storyline advocates noted that they preferred to err on the side of false positives too, and for similar protective reasons. Now, you might be tempted to think this is just another case of what's called the inductive risk, where the cost of an error is weighed along with the likelihood of that error when judging which action to take. Here, it's true that we have two sides disagreeing about which type of error is preferable, but there's much more going on here. There are implicit debates about what counts as good science, in terms of what counts as a satisfactory explanation, and in terms of what people or policymakers really want to know about extreme events. Which questions are most urgent to pursue? Which matters most to society? Eden et al. In 2016, whose co-authors include Freddie Otto, one of the original authors of the risk-based approach, say that the type of analysis of most relevance to users is, in fact, the risk-based approach, as you see here. They write, attribution analysis, it's not advancing. Oh, here we go. Attribution analysis aiming to answer questions of most relevance to data code, or should follow a holistic, that's their term for risk-based approach, in order to prioritize an understanding of the changes of overall risk rather than the contribution of different factors. This last business, the contribution of different factors language, refers to causal analysis provided by the storyline analysis. But as a matter of fact, it's precisely this type of causal analysis of the contribution of various causal factors that is most urgently needed from the current climate model analysis as far as the in-practice intersection of climate and the legal context goes today. In the recent case of Juliana versus United States, the plaintiffs claimed constitutional violations via specific harms they had undergone because of damages from greenhouse gas-induced global warming, for which the US government was deemed partly responsible, having aggravated particular kinds of extreme weather and climatic events in the US. Among the legal questions involved, there is an event attribution question at the very heart of the case. Climate scientist Kevin Trenberth gave testimony using the causal conditional storyline attribution method I've introduced today, supporting many of the 21 plaintiffs. Again, this approach takes certain factors as contingent and assesses the role of climate change conditional on these factors. The US government used integrated assessment, that's a kind of economic modeler, John Wayant, to rebut Trenberth's analyses. Climate lawyers Berger et al. Explain why the Juliana case is so significant. Juliana illustrates some of the challenges plaintiffs may face in establishing a causal connection to individual injuries. The plaintiffs dedicated a large portion of their briefs and expert testimony to defining that causal nexus between climate change and specific injuries And if the case had gone to trial, this would have been one of the key factual disputes. And one critical question for courts as to begin to grapple with such factual disputes is to what extent observational evidence of local impacts, like loss of snowpack at ski resorts or something, can be used to support claims of injury in the absence of an attribution study of a matching geographic and temporal scope, showing that the observed impact was caused by anthropogenic influence on climate change. Simply put, the question is whether it's possible to reason from the general to the specific. Were this possibility of reasoning from the general to the specific to be excluded, it would largely preclude the use of standard tort law to address climate damages from individual extreme events. Because Juliana has now been dismissed on unrelated grounds, the question has yet to be tested in court. But let us review the basic principles of reasoning that showed up in this case and assess how the science of extreme event attribution can be aligned with legal and scientific standards of reasoning, especially the inferences of John Wayant about extreme event attribution and causation. Testifying for the defense, John Wayant said, the reports of plaintiffs' experts, Dr. Trenberth, and he also references Professor Running, which is a different expert, but argues the same thing, do not and cannot reliably tie global climate change due to the defendants' conduct at issue to the claimed injuries they allege affected plaintiffs, because the current state of our scientific understanding is not sufficiently developed. This is because these climate and climate impact models generally cannot determine the regional effects of global climate change to the degree of specificity necessary to causally link to specific weather events, let alone to individuals or any claimed injuries. And when it continued, while the local climate affects the circumstances of outcomes such as crop productivity, coastal damage from storms, frequency of wildfires, and so on, so do other factors such as local economic growth, migration, urbanization, pollution, forest and farm management processes, and so on. The current set of climate and climate impact models cannot separate these factors with sufficient certainty. I want you to keep an eye on that phrase, to disentangle the effect of regional climate changes from the effect of other region-specific confounding factors. But contrary to what Wayant suggests so far, Kevin Trenberth did actually detail the causes of the damage suffered by various plaintiffs in his testimony for them. Wayant then critiqued Trenberth's detailing of the causes of this damage in his testimony for the defense. Wayant has a provocative section title in his testimony called Unsupported Logical Leap of Dr. Trenberth's Analysis. I'm not kidding, which is followed by a claim that Trenberth had failed to make his case for the plaintiffs. Specifically, the analytic support that Dr. Trenberth provides for each plaintiff varies, but all his conclusions of the injuries to plaintiffs suffer from the same failure to connect his conditional approach conclusions to plaintiffs' local circumstances. It turns out this unsupported logical leap consists in the standard logical inference of taking an instance from a generalization. That is, Trenberth is taking a general statement, generalizing over many individual cases or members of a group about a phenomenon, applying to an area of the world or a season, members of a group or a pattern of the physical world, and then picking out one of those cases as an example or instance of that phenomenon, which Wayant describes as an illegitimate leap of logic. It's like considering a basket completely full of red apples, taking one out of the basket without looking at it and saying that we have a red apple. This is not fancy logic. Here's Weyant's argument against trend birth in his own words. He starts, trend birth states, and now we're going to talk about the specific plaintiff, Nathan, has experienced thawing permafrost and wildfires around his home in Fairbanks, Alaska, especially in 2015. Thawing permafrost is uneven and more likely on, it's supposed to say sunlit slopes, and has led to tilted and broken buildings, frost heaves in roads. Wildfires were widespread in Alaska in the summer of 2015. These harms are made worse by human-induced climate change. Sounds just like a storyline conclusion, doesn't it? But Weyant responds to Trenber's analysis that climate change made the thawing permafrost and wildfires more severe around Nathan with, as with his other examples, Dr. Trenber does not address any confounding factors that might have contributed to the specific weather outcomes in Alaska in 2015, the analysis of which is essential to reaching a scientifically valid conclusion about, here's the phrase, any causal role played by human-induced climate change on plaintiff Nathan. So Weyant claims here that because of the confounding factors, no causal claims can be supported about warming causing damages. But we would argue that confounding factor is not even a relevant concept here. The definition of a confounding factor is something that influences both the alleged cause and the alleged effect, introducing a spurious association that is not the causal one being alleged. This is not the case here. We are rather talking about a mediating or contributing factor. And of course, we expect that the extent of impacts from climate change will depend on mediating factors such as vulnerability and exposure. There can be no frost heave in a road without a road. At this point, I'd like to note that in the Juliana et al. Lawsuit, it is a condition of the lawsuit that the IPCC report is granted as providing the, quote, basic facts agreed to and accepted by both sides. As such, the defendants cannot go against the IPCC given the prior agreement. Thus, I will use some results from the IPCC reports to compare with what Weyant has claimed here. And I will note that the very chart that Weyant cites above from the IPCC the IPCC report increased wildfire frequency says it increased with medium confidence, with a major contribution from climate change. With regard to the IPCC on permafrost, in the same table Weyant used above, the IPCC has high confidence that climate change made a major contribution to widespread permafrost degradation, especially in the southern Arctic. These are causal analyses. More importantly, Weyant's scientific reason about human-caused climate change is incorrect. We know from the IPCC report that the science is solid on the cause of human-made climate change on permafrost damage. Conditional analyses of permafrost damage do consider the contributing causes to specific weather outcomes, which may indeed be essential to a complete causal analysis of that weather outcome, but they're not necessary or essential to establishing the veracity, validity, or anything of a basic, primary, or efficacious sufficient causal factor in that weather outcome, which is what human-induced climate change acts as, with high confidence and as a major contribution in this case. The efficacy of this single causal factor of human-induced climate change on the permafrost has been established scientifically to high confidence. The only thing that may be debated by climate scientists may be the size of the effect, but they also seem to be in agreement about that, in that it is a major contribution. Thus, taking the storyline approach, given that the permafrost damage occurred, we ask how much worse did climate change make that damage or impact? And we know the answer to that from the IPCC, high confidence of a major contribution by climate change. So it's scientifically incorrect to say that we cannot reach a scientifically valid conclusion, that's a quote, about any causal role played by human-induced climate change on this plaintiff, Nathan. In sum, Weyant has moved the goalposts for attribution inappropriately to require a complete, detailed local account in order for the plaintiffs to have what he calls, and here's the key word, sufficient evidence for their case. This is, in fact, a classic move of big tobacco, creationists, and anti-science folks from all over, including contemporary anti-vaxxers, if you want to look. But no such perfect standard need be met. The standard that need be met has been met by the testimony of both Trenberth and Running to establish the increased severity of damage to the plaintiffs by extreme events in their neighborhood and areas due to human-made global climate change, which can be shown using both conditional and probabilistic approaches, which in their methods take account of contributing factors. Weyant is mistaken on the science of attribution and on the logic of this case. Now, Weyant makes claims against the storyline approach and its inadequacy to make causal attributions in regional climate change, not understanding how the logic of storyline research questions works for storyline approaches in each case. Given that the extreme event took place, how did climate change alter its impact? Possible and responsive answers are that it made the event more severe, less severe, that was no effect. For Weyant, the devil is in the details of the conditional statements contained in the storyline approach and how they may be legitimately applied. He believes that one cannot reason from the regional generalizations presented in the IPCC, reviewed a moment ago, to the particular cases presented by the lawsuit's plaintiffs. He claims that other confounding, quote, factors will prevent us from concluding that it is actually the global warming contributed to by the US federal government that did a lot of the damage. So we cannot infer from the generalization that permafrost in the Southern Arctic was thawed by global warming to the particular claim that this permafrost in the Southern Arctic was thawed by global warming. But go back to the conditional logic of the storyline research questions. It is legitimate to infer that a particular set of impacts is caused by the global warming discussed by the IPCC. Consider again the permafrost case. The logic of research questions for the permafrost case is, given the damage to the permafrost in the Southern Arctic region, how did climate change affect the severity of the damage to the permafrost near Nathan, all other things being equal? But when objects, we cannot infer from the claim that climate change causes damage to permafrost in the Southern Arctic to climate change causes damage to this permafrost, Nathan's permafrost. But the research question, you notice, is just like given the Boulder flood of 2013, how did climate change affect the severity of the flood, all things being equal? By banning this type of inference, Weyant is banning all such research questions from being legitimate. Surely we do not wish to allow this, since we accept these storyline research questions as legitimate science, as well as their possible and responsive answers. But perhaps Weyant really does not. It turns out he has company. In the write-up in Science magazine several years ago of the Juliana versus US trial, science journalist Julia Rosen starts by confirming that these confounding factors referred to by Weyant are true but irrelevant to whether warming contributed to a particular weather extreme, says Duchandel. Okay, so far so good. But Rosen continues, but Trenberth's approach is controversial, the storyline approach, notes climate scientist Frederica Otto in the United Kingdom. Researchers can now at least partly attribute extreme events to warming, she says, but Trenberth's method isn't able to rule out whether a particular event would have occurred even without climate change. Okay, Need I point out that this isn't the attribution question at stake from a legal perspective or a storyline perspective? On the storyline approach, we determine the various causes for climate extreme events, thus making it more crucial to appearances in the civil courtroom and places where causes of events matter, because we are looking for responsibility for damage or responsibility for future changes. The last issue raised by Otto is a counterfactual about an extreme event's occurrence or non-occurrence. And that's the sort of thing the risk-based research questions analyze. That is, counterfactuals about classes of it, not individual, but classes of extreme events. In other words, Otto says Trenberth can answer his own questions and the legal questions, but he can't answer my questions. But the central issue here is whether Trenberth can address the legal question facing the US government, not Otto's risk-based yes or no question. Oops. What the scientists are trying to do in the case of the plaintiffs is tell whether the extreme events at stake are partially attributable to warming, just as Otto admits that they can be. Storyline research questions have their own merits and their own standards. They should not be judged on the basis of whether they answer someone else's research questions, especially when those research questions may be irrelevant for the interests of those involved legally. And that's what it really comes down to. Whose research questions do we really want the answers to? The risk-based questions serve certain purposes for certain interests, but John Wayant's criticism of the storyline approach in his testimony for the Juliana lawsuit actually demonstrates the strengths that storyline has for highlighting legally appropriate causation. And as the storyline approach becomes more widely accepted and understood, dissents like Wayant's will become rarer and will look more and more illogical and unacceptable. In fact, the storyline approach has become widely accepted since Naomi and I published our paper on this debate just 3 years ago. And what was once a fierce debate lingers on only in some corners of the DNA community. That was my cheery conclusion about the storyline approach until about a year ago, when I saw an article published in Forbes magazine, of all places, by a leading commentator on climate science. Roger Pilkey, who some of you might know, best described perhaps as a conservative sociologist, ethicist, or politician of science, attacked my argument with Oreskes about the benefits of the storyline method as attribution science, saying that it allows too much and is wrongly motivated. He accuses us of wanting to take the storyline approach to attribution because it will allow a larger number of extreme events to be categorized as being due to human-induced climate change. He also introduces the concept of weasel words to represent the causal connections analyzed by storyline extreme event attribution studies. He introduced me simply as a philosopher of biology in the piece. He also calls Oreskes simply a science historian without acknowledging her training and faculty position at Harvard in the geological sciences, while framing himself as an expert merely on, quote, science, policy, and politics, end quote. In any case, he then claims that we endorse this storyline approach on attribution out of, quote, frustration that the IPCC has not definitively concluded that many types of extreme weather had become more common. But he's wrong about the IPCC, and nearly 200 studies performed so far on extreme events show that human-caused extreme events are more severe and more common, as you can see from this slide, where many heat events were found to be attributable to anthropogenic climate change, as well as droughts, flooding, and so on, after the attribution analyses were performed. Pilkey also writes, the rise of event attribution studies offers comfort and support to those focused on climate advocacy by establishing the linkage, and he says, weasel word, of specific extreme events and climate change. It is not clear, however, that such studies offer much in the way of empirical rigor, particularly as compared to the conventional IPCC detection and attribution framework. But he seems to be referring here to a framework that was for a different phenomena, namely long-term inclusive trends in climate, which are an entirely different thing than short-term extremes in weather or climate events. In other words, he's insisting in this piece on applying standards for one type of statistical phenomenon to an entirely different type of statistical phenomenon involving causes of singular events in order to secure the kind of scientific rigor that he seeks. In fact, it's a serious scientific mistake. And our discussion concerned just when and how scientific statistical standards should be applied. And Pilkey evidently had not heard that they had been applied 6 months earlier in the manner we suggested by the most rigorous group of the climate scientists, the hurricane specialists, who've always been the most hardcore and hard-nosed at resisting requests to attribute climate change to any given hurricane or hurricane pattern. Let me be clear. These are the folks who have always resisted attributing hurricanes to climate change. You've seen them on TV saying, no, we don't know whether climate change played a role in this hurricane. But when these hurricane folks adopted our proposed evidential standards in the leading journal on weather and climate science, BAMS, they published the results using Shepard's and our recommended standards side by side with the usual attribution standards, so their readers could see the difference and judge for themselves. Tom Knudsen, Kerry Emanuel, and other leading hurricane specialists tried in this paper an important methodological experiment. When they published results using both standard methods and our recommendation to reduce type 2 underreporting errors for every hurricane basin around the world, users of their analyses will be much less likely to make the errors of underestimating the role of climate change on hurricane frequency, strength, and size because of this study. The stated purpose of the study was to provide more socially useful information useful for planning and adaptation, how to avoid damages from hurricanes and plan for them. They wrote about our methodological recommendations as discussed by Lloyd and Oreskes for future planning and risk assessment. One may want to reduce type 2 errors in particular. For example, planners for infrastructure development in coastal regions may want to consider emerging detection attribution findings, even if not at the 0.05 significance level in their planning and decision making. And it goes to show that Pilkey makes the same old mistake of underestimating the power and utility of having an alternate account operating under different but equally scientific statistical standards. To finish off this story, a brand new paper by a German group led by Ponte, published last month on African rainfall and how pollution might affect that, has adopted our advice in their data evaluation. Ponte et al. In their 2021 article in analyzing long-term trends for seasonal rainfall in Western South Africa outline a complex procedure of calculation and measurement, which includes statistical significance testing at both the 5% and the 20% significance levels. And they say, as discussed in the context of climate change attribution by us and Knudsen et al., the choice of significance level depends on how one intends to interpret the results. However, less strict significance level, the one in substituting for 5%, in addition to 5%, where you use 20%, can still be used for a study like ours that's dealing with a challenge of a relatively short and incomplete data record, subject to multiple influence factors and possible non-linearities. In such a situation, choosing a large alpha, the 20%, implies reducing so-called type 2 errors. Ponte et al. Claim further, taking into account additional factors such as geographical distribution is useful. But ultimately, it is the balance of all available evidence that does or does not suggest that an identified trend has other than natural causes. And this is the philosophy we're following in this study. And note how they conclude this section arguing for the importance of the aims of such studies and using a relevant methodology for such social aims. We feel that such an approach is particularly justified in the given situation as a risk assessment for potential local human influence on rainfall in Southwest Africa is urgently needed. Thank you.
Thank you so much, Professor Lloyd. I'm going to give people a little time here now to transition to Q&A. We have about 10 minutes. Again, you can type questions into the chat and I'll read them, or you can raise your hand and I'll call on you. And while people are getting warmed up, I can start. So I just wanted to follow up on the legal case study. And maybe there's something that I misunderstood, but I wonder if you could talk any more about the concept of causation that is, as it's used or understood in these kinds of court cases in the law. And so, I mean, if I could quickly summarize, as I understood it, one method draws conclusions like climate change made this kind of event more likely. And one method draws conclusions like, given that this event happened, climate change made it worse. And they just seem like very different ways to think about causation. And how does that line up with, or not, the concept of cause as the law sees it?
There is a whole separate treatment in my paper co-authored with Ted Shepard about that exact issue that isn't in this talk. So it's a great question. The way that the law usually treats questions of cause when they're related to any kind of damage claim is through what's called the specialty of tort law. And there are standards of satisfaction of evidence that one needs to satisfy for a causal claim to pass muster in the context of tort law. So, for example, you need to show that there is a correlation between what you're claiming as a cause and the damage. You need to ideally show that there is a causal connection, and most of the time, in fact, in courts, you can't show that, so they make do with other signals that there is a connection, indirect signals and various kinds of indirect evidence. But in the case of storyline, you have direct causal evidence that you can give. And that's what's unusually strong legally about the storyline process. The thing that they never tell you about the risk-based approach is that it is not a causal account. They use it as a causal account. They pretend that it's a causal account. They speak as if it's a causal account, but it is not logically a causal account. You can't get causes out of those kinds of distributions of probabilities unless you commit to a certain type of probabilistic framework, which they're not doing, and unless certain qualifications are satisfied, which they don't, which they are not. So the risk-based people, even though they talk as if they're talking about singular events, which they're not, they're talking about classes of events. And even though they talk about the future, which they cannot, they're strictly talking about the past. And even though they talk about causal accounts, they can't, because their probabilistic risk-based account doesn't give causal accounts. So I'm afraid that the standard of cleanliness of the reasoning in those fields is very unfortunate. And it's only the storyline account that can actually give you the causal account to satisfy there's about 8 steps in tort law, which I can send you the discussion on, but won't go through right now. But I'd be happy to send you our discussion on that.
Great, thank you. I'm still waiting for anything in the chat from attendees. Maybe I will ask one more, and if people are a little lethargic today, we'll put off discussion until tomorrow morning, where we'll all be face-to-face and having a chat. One other follow-up on that, the Juliana, sorry, was that the name? Yeah, Juliana example. You mentioned that both sides agreed to take the reports of the IPCC as the sort of baseline. Is that a common thing in cases like this?
No.
Oh.
I think the right answer is it depends on the case. It's not very common in standard kind of corporate tort law where you've got someone accusing a corporation of poisoning their children, their pets, whatever. And you have to agree about a fundamental set of facts, including this stuff is poisonous, this stuff is not poisonous. They're not going to agree on a set of background facts. So not in that context. That's why it's very nice that in this context, they agreed to a set of fundamental fact finding by the IPCC as authoritative. So it is unusual in a kind of causal reasoning case like this that you would get agreement about that. I think it's unusual. I'm no law expert though. I haven't. I've read about tort law though. And I haven't seen that elsewhere.
And if people don't mind me asking one more while we're here, do you happen to know how the IPCC AR6 is treating these attribution questions and the discussion about which methods?
They're very much more even-handed than they have been in the past. In the past, it was sort of mentioned as an experimental or a kind of ooey-wooey type of way to do attribution. Because even when we were publishing in 2018, we had a hell of a time getting our paper published because we were advocating for storyline being considered on an equal par as risk-based and them as being complementary. There was tremendous resistance to that set of claims in the broad attribution DNA community. I mean, nobody wanted to hear that. But now there's a great deal of acceptance. I mean, I can say this from Peter Stott. I mean, Peter Stott accepts that the two approaches are complementary. And he's one of the founders of the risk-based approach. So it has its diehards, but they are fewer and fewer, and now there's much more even-handed, and you see that in AR6. Yes.
Great, thanks. I'm going to read a question from the chat now. Can you refer us to a good discussion or analysis paper that compare storyline with risk analysis for the ones like me that are new to the storyline? How does storyline compare to the argumentative turn of Hansen, Sven Ovi, Hirsch-Hadorn, with a link there?
Okay. I'm not sure about Hadorn, but I would recommend the 2018 Shepard et al. Paper that, where did that come out? Yeah, I can look that up and tell you tomorrow during the chat. But actually, if you just look up Theodore Shepard at 2018 on Google, you can find this paper. It's 2018 Shepard et al. It's got like 15 authors on it, including Trenberth and the whole crew. That's very explanatory about what storyline is like and how it compares to the probabilistic approach. And another really good one is Shepard's 2019 paper in the Proceedings of the Royal Society that came out in 2019. That's also good. If you can't find the 2018, then look at the 2019 paper in the Proceedings of the Royal Society. Thank you for asking.
Okay, we're just a couple of minutes before, but I'm going to try to squeeze in one more question from the chat. Does the storyline attribution approach help ameliorate issues with the precautionary principle?
Well, you know, it's sort of funny because the big one, probably the biggest, well, the two biggest objectors to the storyline approach have been Miles Allen and Freddie Otto, who created the original risk-based approach with Peter Stott. And Miles has utter contempt for the precautionary principle and thinks it has been, as he states in his writing, he thinks that it has been done and dusted in philosophical literature, and he has a citation for that where he thinks that they have destroyed any argument defending the precautionary principle. The unfortunate thing really is that he has, of course, the storyline people are using the precautionary principle when they leverage up the desire to err on the side of false positives. That's a protective standard. And so it is the precautionary principle enacted, right? That's one of the reasons that Miles Allen hates it the most, and he argues against it. And in a different version of this paper, I actually go through all the nasty quotes he has about that. I took them all out of this version in order to cover some other material, however. But if you want to look at what he says about it, we cover that in our 2018 paper, Lloyd and Oreskes in Earth's Future on attribution. It's in the quotes from Miles Allen are in there, and you can see what he says about the precautionary principle.
Great, thanks. We do need to wrap up now. I'm going to just give a very quick preview of our upcoming webinars. So there's 2 left this semester. 3 weeks from now, April 22nd, Naomi Oreskes will be speaking, and then 2 weeks after that, May 6th, Wendy Parker. And you can go to the Rock Ethics Institute events page for abstracts and to register for those, or just wait for the emails to come around. And that's it for today. Thanks again so much, Professor Lloyd, for being here. And some of us will see you tomorrow at 11.